Today we're going to be solving the following integral. The first step is going to be to factor what's under the square root. We can factor out an x squared. And the square root of x squared is x. So the x's cancel, and we're left with the integral from 0 to 1 of the square root of 2 minus x squared dx. Now we can use trig sub. If we see an equation of the form a squared minus x squared, then we know the substitution we can make is x equals a sine theta. So that's what we'll do. 2 is equal to a squared, which means that a is equal to the square root of 2. So we'll have x equals the square root of 2 times sine theta. Now we'll need to take the derivative. Dx is equal to the square root of 2 times cosine theta d theta, because the derivative of sine theta is cosine theta. I always like to solve for d theta. Then we could plug in. The 0 to 1 bounds are still for x. X squared is going to be 2 sine squared theta. And actually dx is just the square root of 2 times cosine theta d theta. Now we can factor 2 from inside the square root. And we see a trig identity appear. 1 minus sine squared theta is just cosine squared theta. And so we're going to be left with the integral from x equals 0 to 1 of 2 cosine theta d theta. Cosine squared theta. We can pull out the constant 2. And then remember, cosine squared theta is equal to 1/2 times 1 plus cosine 2 theta. So that's the substitution we'll make. The 2's will cancel. And then we could break up this integral. Now we need to find the bounds of the integral. So our upper bound is x equals 1, but our substitution was x equals the square root of 2 sine theta. So if x equals 1, we need to solve for theta. And this is the square root of 2 over 2. And this answer is, of course, pi over 4. Then we need to solve for the lower bound, which is x equals 0. So we'll have sine theta is equal to 0. So theta is going to be equal to 0. These are our new bounds for our integrals. So for our first integral, it's just pi over 4. And then for our second integral, we'll use u substitution. So we'll let u equal 2 theta. Du is equal to 2 d theta. 1/2 du is equal to d theta. So we'll have 0 to pi over 4, cosine of u, and then du is 1/2. D theta is 1/2 du. So this answer, we know the integral of cosine is sine and then plugging back our u, which was 2 theta, we can evaluate the integral. So I'll have 1/2 sine of pi over 2 minus sine of 0. Well, we know sine of 0 is 0, and the sine of pi over 2 is 1, so we know the integral is just 1/2. Therefore, going back, this is going to just be equal to pi over 4 plus 1/2. And that's it.